Okay, let's unpack this. CSS. It can feel like you're just styling a web page, maybe changing some colors, fonts. Simple enough, right?
Yeah, at first glance, maybe.
But then you try to get things to line up just so, or, look consistent across different devices.
And suddenly you're just drowning in properties.
Exactly. Wondering if align cells is the same as align items and why your beautiful design just imploded on your phone.
Happens to the best of us.
So if you've ever felt like CSS was, well, a bit more complex than it seemed, you're definitely in the right place.
And what's really fascinating, I think, is that underneath all those properties, CSS is fundamentally about layout algorithms.
Algorithms, not just styling rules.
Yeah, think of it less like a shopping list of styles and more like instructions for the browser, how it should actually arrange everything.
Okay, I like that framing. And that's really our mission for this deep dive, isn't it?
Pretty much.
To go beyond just listing CSS stuff and really try to get the logic underneath. We've pulled together quite a few sources.
Yeah, articles on core ideas, accessibility, animation tricks, preprocessors.
Responsive design, even a bit of CSS history, a real mix.
A good spread.
And the goal is to pull out those key principles, the why behind the what's, so you can approach styling with, hopefully, a clearer head and maybe less frustration.
Sounds like a plan. So where should we start? Maybe with that fundamental idea you mentioned.
Yeah, let's do that. The idea that the same CSS property can act totally differently depending on the layout mode it's in.
Right. Take width, for example. You'd think width. 2000px always means 2000 pixels wide.
Seems logical.
But as one source points out, that's really only a hard rule in, like, the default flow layout.
The normal way things stack up.
Exactly. Put that same element with width, 2000px, into a flexbox container.
And things change.
It might shrink or grow, depending on the flex settings. It's not an absolute command anymore.
Okay, so the layout mode is like the context, the environment, and the CSS properties react to that environment.
Precisely. It's like the algorithm is the function, and our CSS rules are the arguments we pass in. You have to understand the function to know what the arguments will do.
That makes a lot more sense than just memorizing properties in isolation.
And this brings us nicely to, well, Flexbox itself.
Yes, Flexbox, my mental image is always those bite-sized cocktail sausages on a stick.
Okay.
Yeah.
Explain that one.
Well, you can arrange them along the stick, space them out, change their order. They move kind of independently on that main line.
That's actually a brilliant analogy. I might steal that.
Feel free.
Because Flexbox is designed for arranging items in one dimension, either a row or a column.
The stick, basically.
The stick, yes. You have the flex container, which is the parent element, the stick itself.
And the flex items, the sausages.
The sausages, yes. It's direct children. And the key concepts are the main axis along the stick and the cross axis perpendicular to it.
Gotcha. So how do we control the items along those axes? That's where it gets a bit fuzzy sometimes.
Okay, sure. For the main axis, the primary property is justify content. That's how you space things out along the stick.
Like space between or center.
Exactly. Space between, put space between items. Flex start pushes them to the beginning. Flex end to the end. Center, well, centers them.
Pretty straightforward.
And there are newer values too, like start and end, which are writing mode aware, plus safe and unsafe keywords, which are interesting. They help prevent content accidentally getting rendered off screen.
Oh, that's useful. Okay, so justify content for the main axis. What about the other direction, the cross axis?
That's where align items comes in. It handles alignment perpendicular to the main axis.
So if the stick is horizontal, align items controls vertical alignment.
Correct. You've got similar values, flex start, flex end, center, and also stretch, which is the default, making items fill the container's height or width on the cross axis.
Right, and what if the items wrap onto multiple lines if you have too many sausages for one stick?
Good question. If you've enabled wrapping with flex wrap, or wrap reverse, then you use align content. That property controls how the lines themselves are spaced within the container.
So align items is for items within a line. Align content is for the lines themselves.
You got it. That distinction trips people up sometimes.
I can see why. Now, what about the space between the items? I know margins work, but is there a better way?
Oh, definitely. The gap property, or more specifically, row gap and column gap. It's much cleaner for managing the space between flex items directly. Much less fuss than margins.
Nice. Less code is always good. What if I want to change the order of the sausages on the stick visually?
That's the order property. You just give each flex item a number, and the browser rearranges them based on that number visually without changing the HTML source order.
Super useful for responsive design, I bet.
Absolutely. And then you also have flex grow, which lets items expand to fill available space.
Like if there's extra room on the stick.
Exactly. And flex shrink, which allows them to shrink if there isn't enough space to avoid overflow.
Makes sense. And that brings us back to flex basis.
Right, flex basis. Think of it as the item's ideal or initial size before any growing or shrinking happens, along the main axis.
So it's like width or height, but specifically for Flexbox's main axis.
Kind of. It's the starting point. The algorithm looks at flex basis, then considers flex grow and flex shrink and the available space, and figures out the final size. It's more of a suggestion than width in flow layout.
Okay. And you mentioned there are some subtle differences compared to width.
Yeah, particularly with how it interacts with things like images or replaced elements, and also how minimum sizes are handled. But for many cases, you can think of it as the Flexbox equivalent of width or height.
Now, one headache I definitely remember from early Flexbox days was prefixes, Wenger prefixes.
Ugh, yes, the old, the tweener, and the new syntax. It was messy.
You had to write the same rules 3 times sometimes.
Thankfully, that's largely history. The standard syntax is well supported now. The advice is just write standard CSS.
And use a tool.
Exactly. Use Auto Prefixer. It automatically adds any necessary prefixes for older browsers during your build process. You don't even need to think about it.
That is a huge relief. Okay, so let's tie this Flexbox stuff together. How might you use it in a real-world layout?
A classic example is a responsive layout. Maybe 3 columns on a desktop, but stacked vertically on mobile.
Yeah, common pattern.
So mobile first, you might set flex basis 100% on your items so they each take up the full width and stack.
Yeah.
Then use a media query for wider screens. Inside that, you could change the flex basis to, say, 30% for sidebars and maybe flex grow on the main content so it takes up the remaining space.
Letting it grow.
And you could even use the order property in the media query to change the visual arrangement, maybe move a sidebar from first in the HTML to appearing last visually on widescreens.
That's clever. So the HTML stays logical maybe for screen readers, but the visual display adapts.
Precisely. And one more Flexbox trick, using margins.
Margins. I thought we were using gap.
We are, for spacing between items, but setting margin left def or margin right auto on a flex item does something interesting.
What's that?
It pushes that item as far as possible in that direction, consuming all the available free space in the container along the main axis.
Oh, like pushing navigation links to the right side of a header.
Exactly. The source mentioned a Corpatec logo example. Put the logo and nav in a flex container, add margin right auto to the logo.
The nav gets shoved all the way to the right. Nice. Treating space like a resource you can assign with margin auto.
You got it. Okay, so Flexbox gives us immense layout power, but let's pull back a bit. Think about CSS's core philosophy. Separation of concerns.
Right. Keeping structure separate from presentation, HTML for meaning, CSS for looks.
Before CSS, it was a mess. You had font color red tags littered everywhere.
Yes. Or inline style attributes on every element.
Exactly. Imagine changing a site's color scheme. You'd be editing hundreds, maybe thousands of HTML files. Nightmare.
Maintainability must have been terrible.
Awful. CSS fixed that. You move all the styling rules into separate .css files. Your HTML becomes cleaner, focused on structure.
And you could reuse styles easily, right? Link the same style sheet to multiple pages.
Yes. Huge benefit. Plus, browsers can cache that external CSS file. So after the first page load, other pages using the same styles load faster. Big performance win.
And CSS itself has changed a lot over the years.
Oh, yeah. CSS1 in the mid-90s was the start. CSS2 added more layout stuff. Then CSS 2.1 was really important. It focused on fixing inconsistencies, making things work the same across browsers.
Getting everyone on the same page.
Kinda. Then CSS 3 was a big shift. It became modular. So instead of one giant spec, features like animations, flexbox, grid became separate modules. They could evolve independently.
Makes sense. Allows for faster progress.
And now we're seeing CSS4 modules being developed, adding even more capabilities. It never stops evolving, really.
It definitely keeps us on our toes. Now, to actually use all this power, we need to target elements, selectors.
The foundation of applying styles. You need to tell the browser what to style.
So the basics are things like element tags, right? H1.
Yep. Element selectors. Then you have class selectors, starting with a dot, like dot important dash notice.
And classes can be used on multiple elements.
Correct. Unlike ID selectors, which start with a hash, like hashtag main content, IDs should be unique on a page.
Good distinction. And they're case sensitive.
Yes, classes and IDs are case sensitive, and there are rules about what characters you can use in their names, basically letters, numbers, hyphens, underscores, mostly.
Okay. And then there are those pseudo things, pseudo classes and pseudo elements.
Right. Pseudo-classes target states or relationships not directly in the HTML, like .hover for when the mouse is over an element, or .focus for keyboard focus, or int_child for selecting specific children.
Stuff that changes dynamically or depends on position.
Exactly. Pseudo-elements let you style parts of an element, like first line to style just the first line of a paragraph, or before and after to insert generated content.
Yeah, I've seen those.
Yeah.
Before and dot after ones. They use double colons now, right?
That's the modern convention, yeah. Double colon for pseudo-elements, single for pseudo-classes, though browsers usually accept single colons for older pseudo-elements, too, for compatibility.
Got it. And what about selecting things based on their relationship, like only paragraphs inside a specific div?
Combinators. The space combinator selects descendants, anything nested inside at any level.
So div p gets all paragraphs anywhere inside a div.
Correct. The greater than sign is the child combinator. It only selects direct children. Div P only gets paragraphs that are immediately inside a div, not further nested.
Okay, more specific.
Then the plus sign, plus, is the adjacent sibling combinator. It selects an element that immediately follows another specific element at the same level.
Like h2 plus p gets the first paragraph right after an h2.
Exactly. And the tilde is the general sibling combinator that selects all siblings that follow a specific element. H2P gets all paragraphs after an H2 at the same level.
Wow, okay. Lots of ways to pinpoint elements.
Yeah.
But what happens if, say, two different rules target the same paragraphs? One says red, one says blue. Who wins?
Ugh, the million-dollar question. That's CSS specificity. It's the algorithm the browser uses to decide which rule takes precedence when there's a conflict.
A priority system.
Basically, yes. Different types of selectors have different weights. Inline style, style color.blue, right in the HTML have the highest weight.
Okay, inline styles are king.
Pretty much. Then come ID selectors, #myID. They outweigh classes.
In classic.
Classes, my classes, attribute selectors like type text, and pseudo-classes have the next level of weight. They outweigh element selectors.
So p or div selectors have the lowest weight.
Element selectors and pseudo-elements, first line, have the lowest specificity weight, yes.
So it's like a hierarchy. Inline ID, class attribute, pseudo-class element, pseudo-element.
That's the gist. It's often calculated using a sort of notation like 0, 1, 2, 1, representing inline, IDs, classes, elements. The higher number further to the left wins. It's not just simple addition. One ID beats any number of classes.
Ah, okay. So 100 class selectors won't beat one ID selector.
Exactly. The source had a good example with an inline style overriding a more specific looking selector in a style block just because inline styles have that top priority.
Makes sense. Specificity is key to debugging CSS sometimes. Now, what about inheritance? Do styles automatically flow down from parents to children?
Some do, yes. That's CSS inheritance. Certain properties, mostly text-related ones, are inherited by default.
Like color and font family.
Exactly. Font size, font weight, line height, text align. These typically flow down the document tree from parent to child.
So if I set color blue on the body tag, all the text becomes blue.
Generally, yes, unless a more specific rule on a descendant element overrides it.
But not everything inherits, right? Like borders or padding.
Correct. Most properties related to the box model border, padding, margin, width, height, background color are not inherited by default. That would usually cause chaos.
Yeah, I can imagine. Okay, so we know which styles apply, specificity, and which flow down, inheritance. How does the browser actually place elements on the page? Positioning.
Right. CSS positioning controls where elements sit. There are several schemes. The default is normal flow or static positioning.
Just how things appear naturally in HTML.
Yeah. Block elements stack vertically, inline elements flow horizontally. Then you have position. Relative.
Relative, that lets you nudge it, right?
Exactly. You can offset it from its normal flow position using top right, bottom left, but it doesn't affect the layout of other elements. It still occupies its original space.
Okay. Then absolute positioning.
Position. Absolute takes the element out of the normal flow entirely. It's then positioned relative to its nearest ancestor that has a position value other than static.
Its nearest positioned ancestor.
Right. If there's no positioned ancestor, it's positioned relative to the initial containing block, which is usually the HTML element.
So it can overlap other things.
Definitely. Position. Fixed is similar, but it's positioned relative to the browser viewport. It stays in the same spot even when you scroll.
Like sticky headers or footers sometimes.
Exactly. And finally, there's float. Float, left or float. Right also takes an element out of normal flow and lets other content wrap